and welcome to the second session, if you were. My name is Ray Ritchie and I'm facilitating this session. I'm joined again by Dr. Moray Kidd, who got the afternoon off to a great start, and we've let him have some lunch before this one, so we're not working him too hard. I'm also joined by Francois Disch, Digital Transformation Lead at Schneider Electrical, by Rob Russell, Chief Technology Officer at Senseye, and Gary Harvey, Head of UK Field Services for RS. So we've got a 45-minute session now to discuss technology enabling a step change in reliability to world-class maintenance. We know that your organisations are at different stages of the journey and different levels of maturity, so there'll be a time at the end to ask questions and have a bit of a Q&A. And just before we get started, really, I'd like to invite all the participants to introduce themselves a little bit more than I did. So your name, your role, and who you work for. And it's a little bit disconcerting because you get so used over the last couple of years going, I'll start in my top left-hand box, but I'm just going to start on my left.
Hi there. Thanks. Hi, everybody. My name's Gary Harvey. I'm Head of Field Services for RS. What that means is my team do the mobile part of the maintenance solutions portfolio, things like lubrication and vibration monitoring and so on. My background is in engineering management. I'm quite new to RS. So the first part of my career I was a marine engineer. I'm in the Royal Navy for 20 odd years, and then for the last 20 years I've been working in various settings in industry, in various engineering management roles. In some of those roles I've enjoyed a huge amount of failure. So the subject that Moray's been speaking about today is really interesting to me, and interesting to follow that up this afternoon.
Wonderful, thank you. Would you like to go next?
Yeah, hi. I'm Rob Russell. I'm the Chief Technical Officer and one of the co-founders of a company called Senseye. We're a cloud-based predictive maintenance solution, and basically what we're helping to do is scale that maturity up to predictive maintenance by the use of data and being that sort of 1,000 eyes and ears across your machines in your factory. From a personal perspective, my education is as a mechanical systems engineer, but I've always worked within the software world, mostly within aerospace and defence, working on condition monitoring of aircraft, both onboard and ground-based solutions, and then extended that out into some other regulated sectors such as rail and energy generation before starting Senseye in 2015.
Thank you. Francois?
Hello everyone, so I'm Francois Disch. I work for Schneider Electric. I'm a digital transformation consultant. So it means that I come closer to my end users, Schneider's electric end users, try to advise them on how Schneider can help them reach a higher level of efficiency from their process point of view and from their energy point of view. Schneider Electric is a global energy and electrification digitalization partner for companies. And my role is to explain how to navigate the Schneider Electric's portfolio for our clients. So my role is really to bring about and translate how digital can be useful for our clients. My background is consulting, a lot of consulting for the last 6 years in one of the big boutiques of this world. And before this, for 10 years, I've been looking at all aspects of industrial automation. That includes maintenance and asset performance management. Mostly in oil and gas and power areas. That's me.
Thank you. And Moray, just for those who weren't here before and for our live stream audience as well.
Sure. Good afternoon. If you're online in some other region, maybe it's good morning or good evening. So Moray Kidd, maintenance engineering academic, delivering professional development courses and supporting predominantly PhD research. A background in frontline maintenance delivery and some engineering roles had the opportunity to work in design for civil aerospace companies and power controls.
Okay, we seem to have land, sea and all sorts covered on the panel. So we're going to launch now into our first question for the panel. So if you're looking to improve reliability, what role is there for data, and how does maintenance data support an organisation's ability to operate efficiently? And Francois, I'll begin with you if that's okay.
Yes, thank you very much. So data for me as a digitalization consultant, of course, it's everything for me, right? Data provides you with, as compared to before data was everywhere, to as compared to now where we do have access to a lot of data or can create it, it's about visibility, right? Where, how can we capture an understanding of what's going on around in the operations or the asset performance, like today is it's very much about the asset performance and maintenance. Data provides you with the visibility, right? Visibility to make sure that your equipment, you have visibility on your equipment, but as well, this data can be used across the company, right? And my role is to bring about this data and dispatch it and make it available across the company to the people who need it. And I would elevate the use of data from operations to business applications and make it available to people in the company who probably didn't have before access to operational data.
Okay.
And allow to better plan operations, plan people involvement, and plan CapEx, OpEx investments, right? Running costs. And this is a game changer, right? My role has become justified because it's hard to pull this data out. It's hard to process it. It's hard to make insights, to get insights out of it. And then all this to make it easy to apply and act upon it, right? So this is my
Of course,
job.
the acting upon it is absolutely crucial. It's interesting you mentioned visibility, and you mentioned, Rob, in your introduction about 1,000 eyes. Is that something that resonates with you? This is about making things visible.
Yeah, from the perspective of where we're moving to with smart factories and digitization, the quantities of data are rapidly increasing. And this is where, the approach that we take is to try and help to scale that human role for using technology, AI and machine learning, but using data to actually drive those business outcomes and business successes. But in addition to more than what we would do, say, within an application that sits on top of that, you can actually use the data to actually drive you forward in where you're going to apply the technology. This is something that's become sort of very apparent to us when people are thinking about applying technology to maintenance and machine monitoring. Typically, they go to the place where the data source is readily available and easy. Typically, those are newer machines. And then you ask the question, and it's like, do you expect that machine to fail soon? And they're like, no, it's brand new, but it's really easy to connect to. We're saying, well, maybe we should be looking at downtime reports and maintenance records. So data is important from the perspective of understanding where to have that digital investment and where to focus on understanding the business problem you're really trying to solve as well.
Yeah, where you put that focus is so crucial. It's like the old joke about the policeman sees a man crawling around on the floor looking for his keys and under a street light, and he's like, "Sir, what have you done?" He's like, the man's clearly drunk. He's like, "I've lost my car keys." And the police officer says, "Was it here?" And he says, "No, it was over there, but the light's better here." So, oh, I don't know if that was a groan or a laugh from the audience there. It could have gone either way. But Gary, is this something you see? Like you're out on the field with clients and how they're using data. Is there an issue around reliability, and can this data help them to improve their reliability and operate more efficiently?
I think some of the sectors I've been operating in recently, the concept of harvesting digital data is still very new to them. But it interests me that what Rob's just said there is, though, that in order to decide where you want to perhaps instrument to look for digital data, you might need to start at the basic stuff and data that you're already collecting. And I think that sort of information is collected with varying degrees of quality out in the particularly things like the food and beverage sector, where typically the operator operates the machine, and they then report how well it's working manually. This is an opportunity to blame the engineer, of course, for all of the reasons why they've stopped producing, when many of the challenges are in fact operational. But I think that for me, learning how to, first of all, find out where the big issues are, but then perhaps target them digitally, is a great opportunity to move away from having these perpetual arguments between engineers and operations. So rather than me saying that's a barrier, I think that's a real opening for digital information to help sort that problem out. Because I think once you've stopped arguing about the information, as a team, you can then talk about what you should do about it. And I think in many industries at the moment, they're not even getting past it. They're not even getting to that real step yet. And I think that's where the opportunity lies, really.
Okay, that's interesting. And Moray, because you talked a bit about integration between teams, is that something that you see where there's still the argument about whose fault it is and not using this data to help them all work more collaboratively?
Yeah, and just to echo some of the same points, really, whether it's digital data or more conventional qualitative data, I think the starting point needs to be based on criticality. So what we're not suggesting for those aging assets is to digitize everything tomorrow. It is to start on a criticality basis. What are the machines, the critical bits of kit that, should they fail, they have a big impact on the business? And that's a really smart way to start and then scale from there. One of the real opportunities in the last 10 years, and it's surprising it's taken this long, is the fusion of data. Some of the condition-based maintenance techniques have been around for 30, 40 years and they've worked in isolation, but now we've got the real opportunity to connect to control data. It's been there for a long time. I don't know why this hasn't been commercially exploited earlier. And more importantly, we've got context. Data in isolation is of very little value. When it comes to reliability and maintenance, we have to have the context, the environment, the duty, and understanding of that. So qualitative and quantitative digital data is a real opportunity.
And kind of picking up on that, and it's related, but maybe taking it a little bit further as well. You can't really talk about data without someone talking about data silos. So how can you avoid data silos, and why is it that so important? I think we've already had some suggestions as to why, but are you able to develop that any further?
So another great opportunity, what I'm seeing more and more of, is when it comes to machine learning, a lot of the techniques have been well developed. And in fact, without us knowing, most of us are using them every day. And let's leave that to the computer scientists, to the data analysts. But there's a coming together now of those communities with engineering. So the silo that was there before is really a hybrid team going forward. Engineers working with data scientists, working with procurement and the other departments that we discussed earlier. And so that will drive a real cultural change. And there's a big opportunity there. I've seen time and time again major projects, research projects, fail because they've been conducted by computer scientists working in our space, or indeed professional maintenance engineers trying to develop a new machine learning algorithm. And so we need to work more closely together.
And at Senseye, how would you address the issue of
So fundamentally, the team's a hybrid of people with backgrounds in maybe physics or mathematical backgrounds that have that computer science and machine learning bent. But what's really important is that we've got a lot of people with domain expertise, people that have come from backgrounds in maintenance, in reliability engineering. They front up a lot of what we do in our customer interactions, but they're the key voice of the customer internally and are driving that team forward. And much sometimes to the upset of my team, I actually short-circuit things, and I get my machine learning people to sit in and actually get involved in delivering in projects and give them direct challenges. Maybe going back a couple of years ago, before when we could go out and visit factories, it was always great to take people that had maybe normally just sit in front of a laptop all day and walk them around a factory and get a real feeling for what it's like.
Yeah, I think it's easy to sit, I wouldn't say an ivory tower, but to sit and be remote from it, but actually to be able to see what you're doing and how that works in application. And is that something you see, Gary, when you go out, that actually the application, that there's the application and the theory don't always sit together so well?
I think that's true, but I think there's a real hunger out there for trying to move from wherever it is a site finds itself to somewhere that's better. And what I was explaining the week of a factory, I was trying to find out where they felt they were maturity-wise. I said, do you think you're low maturity, out of control, breaking down all the time, or do you think you're world class? And somebody piped up, well, we're not happy with where we are. We're not happy. And I said, well, that doesn't really answer the question. So the person who's world class still isn't happy, because the person who's got 90% performance has still got someone asking him to deliver 91%, right? So everybody's trying to improve. So what I see is there's a lot of people out there got a hunger to take the theories and the technology that we've been hearing about and get it applied. Mm-hmm. I think what we need to be doing as a community is work across the other functions to get that buy-in from the business, the organisation. Because I think in my question earlier on this morning, it's quite easy to make that case in a nuclear plant. I really need to do this, because you can make an argument for, I've got to do something to that pump because something really bad's going to happen. And everyone can imagine what the really bad happening thing is. That's not as easy a case when you're making it something where it's perhaps annoying that you'll have a stoppage that costs some money. So I think we need to get better as a community to make that case cross-function, because only then will we be able to get near to best in class for everybody, I believe.
Mm-hmm. Yeah. Absolutely, absolutely. And Francois, you began by saying that to you data is everything. Do you have any thoughts around data silos and why it's important to avoid them and how we can maybe begin to do that?
Yeah, so I can give an example of one of our factories, which has been, as Gary said, so it's not 90% efficiency, but it's like a reduction of 30% of energy consumption, reduction to almost zero of the water, reduction to zero of wastewater, to reuse of all the wastewater internally. And you bring all this data mostly from operation, mm-hmm. and it goes to business business level. It gets processed, it gets analyzed. Do we get financial benefits? How much profit? How much cost? How much the costs are reduced? And then it comes back down to the operation guys. So you see, it goes from one silo operations to another silo, which is more finance considerations. You get back to operations. All right. We've done so much, and thank you so much for having improved the energy efficiency of the plant. Let's do 5% more. And they're like, well, it's been hard enough to get there, but okay. Let's have a look. And what do they turn to? Data. Okay, where is it that we have the next silo? Where is the next spot that we can drill down to, right? And data allows you to do this. And you've got those exchanges between the various parts of the company, which are like having their own access to the same pool of data, not silos, same pool of data. And you have those ping pong games that are happening to drive the company to a better performance always.
Mm-hmm. Yeah, I think a lot of people in the room, even if they haven't been in that same situation around data, recognise those dreaded words of thank you for all the work you've done. There's always a but after that, isn't there? Yeah, we all know that one.
Yeah, it's a continuous improvement, as you always call it. Yeah, so let's do the 5% more. Yeah. Oh.
Yeah. Continuous improvement's great, but everyone would like a pause before they do the next bit, wouldn't they? Yeah. Just to gloat in your achievement.
Yeah, you need to pause and celebrate, definitely.
Yes, yeah, before you crack back on. So, thinking, we're talking about moving on, we've talked a bit about data-driven maintenance. And what are some of the common pitfalls that you see around this? Obviously, silos is one of them, but what else is there in the sector that you see, around collating data maybe, or knowing how to use the data in the right way? Maybe, Rob, we can start with you on that one.
Yeah, it's almost gathering that understanding of what you're using that data for and how you're driving it forward. I think maybe to talk in more positive terms, there's these shifts in reductions in maintenance. I've been with customers in the past where we typically go in talking about downtime avoidance as a benefit. Yeah. And I've had customers come back to me and go, Rob, you don't understand my business. I don't have a downtime problem. I solved that 5 years ago. I've got a really extensive maintenance problem now. Right? So they've got to start shifting that maintenance to on condition. So rather than over-maintaining the machines, to remove it. But the sort of successes that we're seeing, our clients now, they've been utilising a data-driven approach to do some of the things that Moray was talking about earlier, understand what's normal for machines, bring out when it becomes abnormal. And now you can start to remove those monthly or weekly inspections of the machines and start to extend those out. So rather than doing an overhaul on a gearbox every 12 months, maybe say we'll run it until we get a signal in the data that it needs attention and drive it that way. And there's even sort of anecdotes we've got from pilots, when I was talking earlier about making sure you use the data to pick the right machines to drive into a pilot in a project. We selected a machine with a client, and they said this machine, or this collection of machines, has failures regularly, and within 3 months you will see several bearing failures on these machines. And we connected to those up, and then we ran the pilot, and then nothing much was happening. And then we're 3 months into the project, and I'm sitting there at a project meeting, and the client, I'm thinking, is going to be really unhappy. I'm saying, we've not had any signal of failure, we're not picking anything up. And then we started to investigate, saying, what else have you done? They said, oh, when we connected the sensors, what we did is we actually stopped doing the weekly bearing inspection. And I'm like, oh my gosh, this was maintenance-induced failures, right, that you had. It wasn't, the bearing failures were all induced by the maintenance policy. So actually, just removing the maintenance and relying on the technology automatically increased the availability of those machines. And it's just having confidence to take that step, but you need to be data-driven to take that step.
Is there anything that you think businesses can do to get that kind of confidence? You know, digital twins, anything like that? How do you get that confidence, especially if you're working in the air industry, where you can't afford for a mistake?
Yeah, exactly. And it's, you know, most of the clients that we're dealing with primarily within that sort of manufacturing and heavy industry space, so there's a high business dependency on those machines. But a key aspect in what we do is make sure as part of the workflow and utilising the data, we're capturing feedback from that maintenance team. So the valuable data source is actually what did the maintainer discover. So you give them an alert, you ask them to go and look at a machine. You might turn around and say, no, this was normal behaviour, or the change in the data was as a result of maintenance activity that wasn't in the system. So you told us an interesting thing, but we kind of knew why it happened. But once you start to gather that along with the benefits that they see, and this goes back to some of those points we were making about having that communication to understand the benefit of the solution. So we are capturing downtime avoided, we're capturing spares costs avoided as part of the notifications that we bring out. So the maintenance team can report that back. We can then demonstrate the return on investment of the platform. But then also it becomes an interesting discussion across business areas as well, where you can start to maybe help the procurement manager understand that we don't need so many of these spares anymore. Right? We're not consuming them so much.
That's a fantastic example, just to come in on that, because I think I often hear people talk about condition-based maintenance, where you're using condition in order to decide whether to do something. But in fact, what you've just made there is equally powerful, in fact more powerful. The point is to tell you when not to do something and tell you to defer something. And I think that's a fantastic example, you know, which I will probably steal and repeat in future sessions.
It's not stealing, it's sharing. We're all here to learn and share.
Yeah. And I mean, I've used condition monitoring very, very effectively, for example, to not clean things. You know, a centrifuge being a good example, where routinely we used to clean fuel centrifuges every 1,000 hours. And sometimes you'd open them up and they'd be immaculately clean. You think, well, I've just taken this apart, risking failure, quite delicate plates that you have to take apart. There's nothing wrong with it. And other times it'd be, you know, need a lot of cleaning. And we used to experimenting using vibration measurement, because the debris that was collecting around the balls, although it should have collected evenly, doesn't. And we just used to measure this thing gradually becoming out of balance and then decide when to clean. So it's about using a little bit innovation to apply some techniques in sometimes quite small, discrete areas.
That's a really interesting example of a kind of very practical application of, like, you've got the data and then, you know, you learn and refine your techniques. And it made me think of what you were saying, Moray, in the first session around, you know, good maintenance doesn't cost you, it should be paying you. And I just wondered if you had any other examples of like that, where you've seen cost savings, you know, either at scale or even like a tiny example that actually makes a big difference?
So to come back to high-risk industries, if you think about low probability, high consequence events, these are real game changers for those sectors, and sadly there are many that have led to loss of life and significant harm to the environment, not to mention the business. In some cases, some of those businesses are no longer around. When it comes to these technologies, if we can prevent just a few of those, I think ethically that's the right thing to do as a professional engineer. We haven't talked a lot about safety today, but in those industries, absolutely. The other thing, coming back to the pitfalls piece around the data, I think there's still a big challenge around what happens if you're producing 1 million tins of product a day, and there are some in the UK that currently are, and you suggest to them that their system is about to go down, only to tell them the wrong thing, and they intervene, and that can become incredibly costly. So we've got to be sure that we are using, again, it's an assisted decision process, but the wrong decisions can also lead to substantial cost implications for the operators. So we've got to make sure that the systems themselves are reliable, not just improving the reliability of the assets that they're monitoring.
Well, as you were saying in that example before, where they introduced a level of failure with the bearings by doing the, Francois, is this something you've seen across, where you are now and maybe in previous roles, where there's pitfalls that are happening because of what's going on?
I would say back in the days where I was more specifying how control systems or be on the receiving end of the specification for control systems for power plants and oil and gas installations. We've got quite a interesting list of things of box to tick, which are not all converging into making the data easily available. So if I turn your question into how early could you actually influence what's going to come down later down the line with a failure of an asset, the way digitalization of that asset is actually brought in at the stage of the building of the plant, the building of the installation, the creation of the installation. The responsibility of engineers and their involvement of engineers in who are going to deliver the project needs to have maintenance. Their involvement needs to have maintenance on the top of their mind, and answering to the specification on the whole list of tick boxes. It's the responsibility of the vendor to make it converge into an easy way later down the line to make it to give this this data, this operational data, to make it available to the people who are going to use the asset. So at this stage, this very early stage of the review of the creation of the asset, we should have this in mind. And this is one of the failures that I've witnessed. I've witnessed myself, and try to steer back into okay, what asking the right questions. How are you going to use this data? How are you going to make it available to the operational teams? Are you sure that you need all those alerts? Can't you just filter? Can you have a way to make it more sensible for the operators? On this, those are the questions to ask on a greenfield project. So,
okay.
Just to add to that, so the sort of principle that we use, and it's just building on Moray's point as well, is we very, very much think of these systems as decision support tools. There's always a human in the loop, but the real key is that this data is increasing at an exponential level, and the use of technology is in and around scaling the role of the human. Right? These reliability engineers and diagnostic specialists and even maintenance teams, these are a finite resource. Humans don't scale. But if you can use the technology to help them and focus down into where the actual problems are in that population of 2,000 machines in the factory, what are the 5 or 10 that I really need to know about and worry about today? And that's the way it goes forward. And this all aligns to addressing, there's a lot of hype and myth in and around what we can actually achieve with analytics and machine learning today, right? We're very much in a world of narrow AI, not broad AI. You know, it's not quite Star Trek yet. The computer will do and what we sort of tell it to do. And we apply that into quite a focused area and a focused domain, and ensuring though that it provides a scalable solution, and we will still have a human in the loop to validate that decision at the end of the day.
Yeah, I think that's something that's very easy to forget, actually. We're generating this data, but the analysis still generally comes from a person. And do you think this new and increased amount of data is meaning that organisations, is there a kind of need for newer digital skills, and do organisations, do they have that amongst their staff, or is there a need for, you know, more training and more awareness of how to do this data analysis?
Yeah, so what we've seen since, you know, over the years since we've been working within Senseye and selling, so typically our targets would be like engineering and maintenance directors, but now we're seeing actually it's digital transformation teams are the ones that are driving this forward. They're realizing that they have to assist those more hands-on and technical disciplines within their organization to know how to deal with the data and create those architectures that do allow it to be a scalable solution. And again, it is all about scale. We're moving here from a situation where people would be monitoring maybe 10 to 100 critical assets in their plant to connecting up thousands of assets across their plant. And it needs to be done in a considered way and with technologists that understand the upcoming pitfalls in that. So having that ability to be much more digitally savvy is key. And another big aspect is the blurring of the line between the operational technology on the shop floor and the business technology in the IT system. We very much see roles emerging where an individual that you would think would normally just be like a controls and automations engineer is now starting to become familiar with databases and APIs and pushing data to web applications and data stores. So there's a gradual tendency to expand that capability, and the technology is now emerging and coming that's supporting them in doing this.
I mean, I think that's a really big point you're making there, Rob, actually, because one of the things that I've worked within industry is that up until recently, not only did the IT community not work with operations and maintenance, they in fact have deliberately diverged, and the expression they literally have an air gap between these two systems. And so that they didn't, not only did they not want to work together, they tried really hard to become separate. Earlier on, we were talking about the need to make some consensus if we're going to succeed in engineering and break down some of these silos. But I think what you've just said there, this is now going to happen naturally, because in order to take advantage of cloud-based data, you need, by definition, to get these two communities to work together. And I think once you've achieved that, it seems logical that, you know, the other people who have been standing on the sidelines, such as you know, procurement, finance, and so on, can then start to join in with that conversation to make the whole thing work, because that's the only way that it will work, I think, isn't it?
Exactly.
Yeah.
And Moray, I know you're very involved, you know, literally in your job in the education sector. Do you think these skills are readily available, these abilities?
I think there's a massive opportunity for higher education in general. For many years, we've worked together collaboratively with research across these different departments and schools, but we don't do it on the educational side. When it comes to undergraduate teaching, very conventional. In my own department, mechanical. In my own school, mechanical, electrical, civil. School across the road, chemical engineering. And then computer science, so detached, different faculty. And so I think there's a real opportunity to create new degree programs and lower to the apprenticeship schemes in terms of training, to create these cross-discipline taught programs to meet the needs of business going forward.
And Francois, I believe you have a slightly different take on this kind of topic. So, do you want to share what?
So I flipped the question to actually, yes, there's a skill gap, but funnily enough, in that same plant that well, we measured a lot of things on this plant because we had data. That same plant I was referring to before, we had following the conversion or the official, let's say, conversion or branding of this plant as a, well, this is a smart factory. We had 40% more unsolicited applications to this plant, meaning that we were attracting more people to get to work for us in that plant because they were interested, right? So, and it was not just a digital consultant like me, right? It was people on the shop floor interested in working in those improved conditions with more data available, more being in contact with you know, the apps on the digital context that we have in our own lives, right? When we get a Uber or check news or get the info we want from our smartphones. Well, this is kind of the context that they have in this factory, right? They have meetings, shift meetings in front of a screen with live data streaming, right? What happened in the last shift? What happened in the last month? Where are we next to the objectives as compared to the objectives? And on this context, so helps attracting people at every level, right? So yes, we need to definitely train people. We need to change the program so that data and digitalization, and the digital way of approaching things is part of our core subject areas, yeah? Because business is like this. But if you're struggling to recruit, struggling to find those talents in the market or out of universities, what you can do as well is attract them instead of pushing. It's kind of a pull, getting them by attracting them because your company, because your methods are based on digital.
Wonderful. I think that's quite a nice positive note on which to segue into some of the questions we might have from the floor. We do have some come through online as well. So to give you a bit of warning, if you have got, think of a question if you do have one, but we'll start with these online ones. So how is the 5G step in the UK? And that question comes in from Aracho. Anyone like to
speak about 5G?
Yeah. So 5G actually becomes quite interesting in the fact that, you know, as the standards emerge, it's much more than the 5G that we'll see as consumers. It's not about downloading an entire movie in 2 seconds. The other parts of the standard that are coming out relate much more to smaller packets of data, and many of those, but also gives you the facility to create those networks within your factory environment. So you can bring that network down inside of the factory and have something there that is going to be suitable for the types of data that we're talking about. I remember back probably around about 2014, 2015, somebody asked me that was having a 5G, they were organising a 5G event, and they said to me, Rob, what do you want out of 5G? And I said, actually, much better 2G. I didn't get invited to the event, but what is actually happening is that standard is expanding to actually address that, because it's lots and lots of small packets and chatter that's going to be happening there, and that will be a key aspect and that we'll see 5G and how it will impact industry.
Okay.
So, if I may, yeah. So 5G is I wouldn't say it's going to be a revolution, at least for the application in smart factory, but it's going to be a big change. We're going to have the ability to make our networks reliant on a much wider areas, much wider application type of applications, streaming video, on analytics on the edge of videos or live analytics of videos is going to be made possible. You will have the network topologies in the factories is going to change completely. So this opens opportunities which are worth watching closely, right? Reliability of the 5G networks will change as well. We're gonna get away from this patchy Wi-Fi network to something truly reliable inside the factory, outside of the factory, on the the parking lot where you have all those yellow diggers parked next to each other, and have the accuracy of the data on the location information and live monitoring available. Yeah. So 5G is going to be an interesting topic to watch.
We've got another question come in that I think before we open to the floor is worth covering, because I think this will be on top of a lot of people's minds. This is from Andrew on LinkedIn. Will security for key data get better? So Moray, do you want to?
I think this is a massive challenge, and it comes back to the discussion this morning around the value of non-physical assets, the value of digital data. What we didn't speak about this morning or yet is intellectual property. And I think we're not long away from a much better understanding of how the digital data, the non-physical assets, becomes the key intellectual property, not the physical assets themselves. And that's where security becomes really important. Where you're working with companies that are providing services, I think there's ways around that in terms of not having complete access, if you like, to the crown jewels of the business or their intellectual property, and you have these dedicated portals to gain access to data and context needed, but there needs to be some real thought around security, stability, maybe even impacting the reliability of the systems themselves by intrusions. A lot of these systems control systems were designed to be control systems. If you start asking them specific questions about health condition, energy consumption, is that going to impact the decisions that they make? And there's an integrity issue.
Okay, and Gary, is this something you see when you go out into the field? Are people concerned about the security aspect?
I think in general at the moment, that's a big cultural as well as technical issue. I know that within RS, the industrial team who go out to work with industrial clients have got and have had to have dedicated security resource to make sure that what we're building meets that requirement. But step one is to get the potential customer willing to even have a conversation about access to data and putting data into the cloud, because there are many companies out there that have actually got it written into their procedures, thou shalt not put data into the cloud. So step one, and I'm sure Rob will have had to experience this himself. Step one is to convince them and evidence the fact that you can do this securely, and I think that's so. I think although we feel the technical, and Rob will speak, know far more about this than I do, but we feel that the technical challenges are surmountable, but you've got to be able to have a conversation about that to begin with, I think. Yeah.
That's, I think, been such a big theme of the whole discussion, really, is around the culture is almost as important in some ways as the actual technical side. We have a couple of minutes left, so are there any questions from the floor? I think we have an eager beaver here. Yes. Sorry.
Oh, hello. Thank you. So much has happened, say, in the last 10 years in what we're doing now and where it's going. What do you think it will look like in 10 years' time?
Good question. Anyone want to jump in?
I've got some thoughts, possibly controversial. I think there are everything I've got is controversial. I think the guys would probably agree with me here. I think there are certain sectors, particularly those where an engineering solution on its own is possible. Let's say running a wind farm, for example, where there's very little human intervention. We're not making anything particularly other than the energy, of course. I think those types of sectors will see radical changes over the next few years, because they will be either equipped, able, or have the money available or investment to take advantages of the new technology, going forward. I think we'll see other areas of British industry which will be slow adopters of that technology, and some of them won't move at all. Hence, the reason why Moray's lecture this morning is very interesting. We have got factories out there that not even are they not investing in the future, they're not keeping up to date with obsolescence. I've worked in a facility where we've used eBay to find stuff, and there are plenty of them still out there. And sadly, I think that'll be the case for probably the next couple of decades as well. I first trained as a vibration analyst in the late 1980s. I think if you'd asked me back then whether portable vibration monitors and stuff would be still in use 30 years later, 20 odd years later, I think I would have probably said no, I don't think there will be. Surely we'll have had something better by then. And we have. But industry isn't adopting it yet. And that's why there's going to be work for my lot for the next 20 years. But I think other sectors will work and will move much more quickly. Would that be fair, do you think?
So, if I may. So, yes, if you look at decades, we're talking about Industry 4.0, data monitoring, maintenance, data supporting maintenance, right? Rolls-Royce have been monitoring their turbines on planes since the 70s, right? So Industry 4.0, that's Industry 4.0, right? If we want to put it, look at what the definition of Industry 4.0 is, and how they applied this data management. That was very early, right? We are in 2022. It's been 50 years, right? But it was justifiable for flight engines, right? So for turbines on aircrafts. It's probably not the case for bottling plants. The business case is different, okay? What I have seen over the half a decade of consulting that I've been working on this subject specifically, I've seen a lot of companies asking themselves the question 5 years ago, and now when I'm coming to ask the same question, the spectrum is much wider. I see a lot of evolution. I see a lot of people being across the spectrum of maturity on data use, right? It's not only Rolls-Royce, which is at the end of the spectrum. You've got other players. Schneider is one of them, but you have a lot of people who are leaving this digital era. So I'm probably more optimistic than you, Gary. I see this moving a lot in the next 10 years.
You did utter the words, if we're talking about a definition of Industry 4.0, and I've been in the RS world long enough to know that's the time to stop, because we're going to open a whole other can of worms if we start talking about that, and the clock is flashing red, so something bad might happen. But yeah, we have come to the end of our time. I'm really sorry that we haven't got to all the questions on the floor, but I hope you agree we've had two excellent sessions today, first with Moray's lecture and then with this discussion, that I could tell it could get a little bit more fruity if we had another half an hour or so. We hope they've inspired you and supported you to think about maybe where you're going with your work and your organisations. And if it has made you think about something in particular, the exhibition is open for another hour, I think, so you can go and have a look round to ask any further questions you want to. Otherwise, I just want to thank you all for attending this session and attending the RS Connect event more generally, and to thank all of our speakers, so Moray, Francois, Gary and Rob, for attending. So thank you so much.